Hello beautiful people and welcome to a new video from Federico. It is very hot here, Munich. It's not comparable to Rome, where I am from, which is much hotter, but still was pretty hot. So in this video I'm going to show you how to create this effect. Basically we are going to use the MediaPipe code from a couple of years ago from Rob Ramirez and Lixdesic. To create this effect, which I saw on Instagram some time ago. Not exactly this one, but basically this thing of creating a rectangle with your hands and then applying an effect to the image with the pixels inside this rectangle. This is going to be relatively simple. So if you're interested, grab your favorite cold drink and let's jump straight into it. So first thing, we want to go on this link, which I will put in the description on Rob the Rich GitHub. This is Rob Ramirez from Cycling74 Jitter team. And we go here on code and then download zip. Now I have already downloaded this and unzipped it inside this folder. And now we want to open this patcher hand pose max part. Okay, and there we go. You can see that this patcher is tracking the hand's position, actually the fingers and all the joints, and is converting this in some sort of sound. Now, we don't really care about the sound. We will get rid of all of that. We will also get all this documentation, very nice, and we will put it inside a subpatcher. Maybe we can use it later. And great, so now what we need is the position of the thumb tip and the index tip. Okay, we want to create that rectangle, so we need these 4 points. So you can see this is how the values are organized inside this dictionary. So the MediaPipe, the jweb object, will give us a dictionary, which we saw in a couple of videos ago, how dictionaries work. So it's a pair, it's a key value pair. And so the key being like the right hand and the landmarks, and the value being the position. Now we want to get landmark number 4, I think, although they start from 1 in the dictionary array. So I guess this is number 5. So let's see. This is, see if I can just make this long enough to see the position of the thumb. Right. So this being the right hand, which is actually my left hand, so this is a bit confusing. It's right on the screen, but it's left for me. So maybe there is a way to flip that, but I don't see anyone. I don't see any way that is obvious. So we will leave it like that for a moment. So let's see. This is the thumb, should be number 5, right? I think it is because let's see. If I only move the thumb tip. If I try to move only the thumb tip, this is what changes most, I think. So yeah, after this empirical test, I think number 5 is the thumb. So what we want to do, let's get rid of those. Let's actually get rid of those as well. We have here a little subpatcher that, so let's see what this little subpatcher gives us. So this is a dictionary. So I think we can do it in a different way. We can just say dict.unpack landmarks. And then this will give us, it should give us an array. Yeah, so that's an array. And then we can say array at 5. I believe that should be our thumb joint. And this is an object dictionary. So if we pass this into a dict, or we can even just look at it with dict view. Now array was not available when this patch was first made, so that's why I think it was not using array in the original patcher. But we got arrays, so we can do that, and then we can say dict unpack x and y, and this will give us the x and the y position of the thumb tip, theoretically. So let's see. And these are normalized between 0 and 1. So if I go all the way to the right, it should get close to 1. Well, it should be actually past 1. So not sure why it just gives us 0.9. But all the way to the left, it's a bit mind messing with my mind, is fact that this is reversed. But yeah, maybe is the number 4 the thumb tip? It looks more like it. Yeah. Okay, so number 4 is our thumb tip. And this is so that's the left hand, or actually the actual right hand, X and Y. And we can do the same with the other hand. So now that we got these values, we should get the index values. So the index, if we consider this is the thumb tip, the index fingertip will be number 8. So we can have another one of those and say that's number 8, array at 8. Same here. Array at 8, and we should have the position of the index. Finger going from 0 to 1 on the X and Y axis. Okay, that's great. Now I still want to use our camera input actually. I don't want to view the final render in the jweb object. So what I want to do is probably to get the BZ input grabber module. Just drop it in the patcher. That's a very nice way to get all of our camera input. I will just set it to 1920 by 1080. For some reason, it's also messing. It's also changing the resolution here. So this needs a JIT world to run. So there we go, JIT world. Floating one, being that this is outputting a texture, I think. So floating one, FSAA, size 320 by 14. Let's enable that by default. And then I'm going to just get the enable attribute here, so we can bring it out from there. And let's see if this is actually outputting anything. Doesn't seem so. So with JIT is working. So not sure why it's not working with our grabber module here. Okay, so let's just use the JIT grab instead. And what I did is just to select my device, which is this one here, number 1. So I can just say v device number 1, and you will have your own device list, or you would just use your computer camera, so that's totally fine. But in any case, you can go on the help file of JIT to get this little assistant. Couple of view menus to see what devices are available for you. So that's good. Now we want to process this input image using ggl_slab object. And we're using ggl_slab because we are going to apply this effect in a shader. That's how we're going to make this rectangle come true. So when we first open that, we will be greeted by this default shader. And let's actually get rid of this teacher, which I think is consuming a lot of resources by just being displayed all the time. And we also don't want to print anything here. So yeah, I was saying, when you double click on that, you will be greeted by this default shader. Now we can work with that. So let's go here and file, save as. I will go inside my folder and I will save that as video fx.jxs in the same folder where our patcher is. So it will be found by the patcher. And if I double click on it again, the file will be open with my default text editor, which is Visual Studio Code. And I want to select JLSL as the language for highlighting. You can also select C, And cool. So this has a bunch of inputs, which are, for example, a param call scale, which we actually don't need, so we're going to get rid of. Model view projection, matrix, suggestion, position, text, color. This is all stuff that we need, so we're going to leave it like that. We're basically not going to touch the vertex shader. What we're going to do in a fragment shader is get rid of this uniform that we just deleted. And we also don't care. We also don't want to use it in the code. So what we can... Oh, and I also will give it as a file name to this GGL the file name of the shader we just saved. There we go. And I can actually input that inside GGL and then I can send this to a GGL layer, which will then display the image on the rendering window. So the first thing we got to do inside our shader, now that we got it open in Visual Studio Code, is to ask ChatGPT, in my case, how we can check in a fragment shader if the pixels in the image are inside the rectangle made by 4 points. There is a way to do that, of course, and it involves these 4 functions, which I'm just pasting and copying from my ChatGPT query, and you can just copy them right now. You can do your own ChatGPT query, or if you are very curious, you can learn about how this works. This is basically just cross product. So these are the 4 functions. Let me write this down. Functions to check if point is inside rectangle. To the point, basically. So the first function we need is a cross product in 2 dimensions. Then we need this function which is called same side, and then we need the point in triangle, which uses same side, and then we use point in quad, which uses point in triangle. Now, how this works, this is not at all completely clear to me, so I'm not going to explain it to you, but if you're curious, you can definitely research more on this topic. I just want to get this working. So once we have that, we need these 4 points. We need the point, the input point, which is going to be our texture coordinates, and then we need the A, B, C, and D. Now, these points need to be in a certain order. A is going to be the bottom left, B is going to be the bottom right, C is going to be the top right, and D is going to be the top left. So that's how we should pass these values inside. So these are going to be our 4 fingers. These are going to be the points that we use for that. So let's create 4 parameters here. And we can call these thumb, or actually left thumb tip. This is going to be of type vector2. Default, we're just going to set it to 0, 0. And then we're going to copy these 3 times. So the bottom left is always going to be the thumb, and the top left is always going to be the index. And same here, top right is going to be the index, bottom right is going to be the thumb. The fact that this is flipped messes a bit up with my reasoning, but this thumb here is going to be the bottom left, while the index is going to be the top left. So let's start with that first. Left thumb tip is going to be the bottom left. Let's actually call them like this, you know. Bottom left, top left. Then bottom right and top right. Okay, so we need to then bind those inside to the fragment shaders. So we're just going to say bottom left. We bind it to program. The program is called FP. And so on for the other. Oh, and I wrote progra. So let's do like this. So this is going to be top left. This is going to be bottom right. And it's going to be top right. Okay. So once we have those, we can declare them inside the fragment shader. These are all back to, and what did we call them? Bottom left, top left, and so on. Top left, bottom right, and top right. So let's go inside our main function of the fragment shader, which is the function that is always called by the system, by the rendering pipeline, to draw the single pixels of the image. And let's create a bool value and call it is inside. So this is going to be the 0 or 1. And then we can say point in quad. Now the first input is going to be the coordinates going from 0 to 1. So these are going to be our texture coordinates. And luckily we already get them coming in from the vertex shader. You can see these are passed in this structure that goes from the vertex shader to the fragment shader. So we got those text codes already, and they will go from 0 to 1. Probably at the moment they are going from 0 to the size of the image -1, so we're going to need to normalize them, but we will do that later. Then we need these 4 points, and we need them in this order. So bottom left, bottom right, that's how it needs to be. Then top right, so anti-clockwise order, and then top left. Now let's just multiply that by is inside transformed into a float. If it was just a bool, it will not work. So in this case, we can see if is this working. Now we need to pass those values. So let's see. This is the left hand. Right, so this is going to be our thumb. So let's pack here, bottom left, 0, 0, or FF. I'm going to do like this. This is going to be our top left, FF. Then we get here our bottom right, and we get here our top right. And then we can prepend param, because GGS Lab needs the param keyword before we can set the uniforms. So there we go. And let's see if this is working. It's not working, so my guess is that we are getting the texture coordinates not normalized. So we need to normalize, and to do that we can just pass a rectangle 0 here. And this is again not working. So let's see. Let's just visualize this. So we'll just create a vector 4 with the result of is inside. And okay, it is actually working. Fabulous. Possibly the fact that I made the window smaller is influencing the coordinates. So what I'm going to do is make it as big as it needs to be. And we can see that this is now working. Okay, cool. So one thing we can do, like a simple effects, once we have that, is to just mix between the default color, which is going to be texture, the name of our texture, which is text 0. This is all passed automatically in the default shader. Text 0 and then jit in.text card. So this is going to be the default color. It should be just passed through in this way, right? And then we can mix between that and 1 minus default color, so basically the negative of our input, using a is inside as the deciding factor. For some reason, when I use it like that, then it doesn't want to work. So what's the matter? Let's try to use it as a bool. So we can say if is inside, then just output out color it's equal to 1 minus default color. Otherwise, out color is equal to default color. And let's see what we get. And again, it's not working. I want to try again to just set out color as is inside, just to see if it's actually still working. And I guess we need to convert this to float first, otherwise it's going to give us an error. So this is working. I wonder if it's because Jitter still has the old texture on it, and when is our window disappears, so sometimes this happens. There it goes. Okay. So let's try again to uncomment that. See if this now works. Yes, it works. But it's not giving us the negative, and that's because the alpha value of this value is going to be 0 then, and GGL layer has transparency alpha blending enabled by default. So we will just set the alpha manually to 1, and there we go. So let me show you. Okay, that's pretty cool. And we could do a lot more cool stuff with this effect. We could include the noise, we could include blurring like I did in my demo patcher, which I showed you in the beginning. But for this tutorial, I think it's okay to just leave it at that. Now, some more advanced models use confidence to tell you when the computer is not really sure that it's really seeing the hand. Now, this model doesn't seem to have it, so we cannot really use the confidence to make the thing disappear. So it's going to be a bunch of artifacts not looking really clean when the hands go out of the screen. You will see still the rectangle, so that's not really nice. But one thing in which we can filter those artifacts is to say if the distance between the Y position of the index and the thumb is less than a certain amount, then we can stop displaying the rectangle. So in order to do that, we can just do like this. Let's get the difference between the top left and the bottom left, for example. And this is going to be, actually this is the top left. So if it's less than, let's say, 0.05, something like that. If it's less than that, then we can first filter out repetitions with a change object. And then if that's the case, then we can just set everything. So let's say select 1. If that's the case, let's set both the X and the Y to -1. And we will do the same for the other hand. We will set everything to -1 if that's the case. So now that we know that if this happens, this gets set to -1, we can say that if this is inside and say bottom left dot x is greater than 0, then do that. Otherwise, not. And bottom left is greater than 0 and bottom right dot x is greater than 0. We just need a couple of values from each hand. So let's see. And you know what? I think we should get also the absolute value, because we want to have we don't want to, it doesn't matter if it's negative or positive, we just want to have the value. Okay, so I think it's because this is still sending the values even if we set the -1, then it's still sending. So we should set a gate here. A gate that is closed in case this is true and open otherwise. So okay, this is getting a bit full here. So let's create a subpatcher for that. This is going to calculate the vertical diff, and the gate will not go there. So this will, let's put a param down here. Vertical diff. So the gate doesn't go there, but goes actually here. So we should stop the... this probably could be done differently and better, but we should stop the numbers going inside there, if that's the case. So let's create an output here that happens before the other. So we can actually make it explicit by using a trigger. So this happens, stopping the numbers from coming in. Then this happens and sets the new -1 values, right? So we should probably create an abstraction for that, but again, this is something that you can do on your own if you want to be very neat about it, to basically reuse the same code for those two subpatchers instead of having a subpatchers that you have to manually modify every time you change something. So let's see. This is very... what are we using? The bottom left and the bottom right, so we probably don't need to gate the top right and the top left. Actually, we probably don't even need to gate the bottom right y value, because we are only checking for the x value in the shader. Anyway, so we are stopping the numbers from going inside the bottom left and in the bottom right, so if the vertical difference is small. So let's see now what we get. Vertical diff. Okay, so seems it's nothing is going through. Okay. So what's going on? Seems nothing is coming out of that. So 1 less than what? (0.2) is not less than 0.05. So why is this giving us? Why is this giving us a 1? So this is giving us a 1, even though 0.2 is not less than 0.05. So I'm not exact. Oh, you know what? The absolute value is only using integers. That was it. This always gets me. So again, probably better to use an abstraction, but we're lazy. I mean, I'm lazy. Let's see. Okay, silly me. This is reverse. So if this is greater than 0.5, then open the gate. So we should reverse that. That logical gate should be reversed here. Let's see if I finally got it. Okay. So if these fingers are very close, the effect disappears. Right. You know what else comes to my mind? We could, for example, use one of the awesome jitter effects objects, like pixel sorting. This sounds funny. So let's see how this looks like. Okay, this looks like this. It's very heavy on the frame rate, so let's maybe go on with brass. Let's see how heavy that is. Okay, so we could do like this, basically send this texture here. Oh, and it seems he wants texture with non-normalized coordinates to work. Okay, no problem. And then we can send it as an input again to the GLSlab. And then here in the code, we can add another texture. It's going to be texture 1, index 1. We need to bind it as well to the fragment shader. And there we go. It's going to be text 1, sampler JIT1. This is a built-in type for texture in GLSL in Max. And then I think, though, this will not work because this is not normalized coordinates. So we need to also send a new set of coordinates to the fragment shader, which means we need another texture matrix, which is a texture 1 matrix. This is necessary to calculate the new texture coordinates, which we then need to bind here to the vertex program. Now, in the vertex program, we need to send another set of text code for the second texture. This is texture matrix 1. So texture 1 is going to be texture matrix 1 multiplied by text code. Text code is always the same, always go between 0 and 1. These are the values for the vertex in the plane that is displaying the image, so this is always the same. Now inside here, we set this to 1. And then we can say back for fx color is equal to texture text 1 jit in dot text code 1. So let's see, the out color is simply going to be here. In this case, out color is going to be fx color. Let's see if this works. And it's not working at all. Wonder why? Let's see if this is at least coming in. It's not coming in. Now it's coming in. And now it's working. Okay. So you can see where I'm getting at with that. We can use whatever effect we want, and this is going to appear in our rectangle made by our fingers. It's pretty cool. And you can also, of course, make custom effects in the shader. It's going to be lots of fun. If you do that, you can also use LLMs to help you with that, as I did. No shame in that. Nobody can know everything. Sometimes you just want to have fun. So that's it for this video. I hope you like it. And if you want to grab this patcher, you can go on my Patreon, sign up, and get it, together with all the patches I shared during the years. So it's a pretty good deal if you're interested in making patches with visuals with Max and Jitter. And as always, take care, have fun, try to stay cool if you are in one of the places which are super hot at the moment like me. So see you later. Ciao.